Symbols and formulas. A symbol is a shorthand for elements. So instead of writing out the whole element name, you can just write the symbol of the element, which is a capital letter, or if there's two letters, the first letter will be capitalized and the second one will be in lowercase. And they take the symbol from the name of the element. So for example, C is for carbon. Now looking on the periodic table, there are some symbols that seem to not match the name of their element. And that is because they use the ancient name of the element. So for example, Au is the symbol for the element gold. They take the Au from the ancient name Arum. Ag is silver. Cu is copper. So these are all elements that existed anciently. Na is sodium. K is potassium. And Hg is mercury. So you just have to watch out for those, and just an extra memorization step. Now let's talk about formulas. A formula is a shorthand for compounds and molecules. And what's important about a formula is it shows the number of elements present. And it specifically shows the number of atoms in a ratio, and we use the symbol of the element in the formula. So let's look at our first formula here, one that most people are familiar with. So H2O. This has the common name of water. And what does it tell us? It tells us there are 2 hydrogens for every 1 oxygen. Let's look at the next one. So the next one, we have nitrogen and we have oxygen, and they are combined in a ratio of 2 nitrogens to every 5 oxygens. This next formula is aluminum nitrate. Now in aluminum nitrate there is a polyatomic ion, and this polyatomic ion is NO3. Parentheses are used to show that we have 3 nitrate polyatomic ions for every 1 aluminum. You can further break down each of the elements in the polyatomic ion, and we would do this by distributing that 3. So those little parentheses we would multiply through. So how many of each element are in this formula? We have 1 aluminum for every 3 nitrogens for every 9 oxygens, because 3 times 3 is 9. Let's do the last one. So this is magnesium hydroxide. Again, we have a polyatomic ion. Its name is hydroxide, OH, and we do have 2 of them. So the polyatomic ions are never split up. They have a parentheses whenever there's more than 1 of them. So we have 1 magnesium for every 2 times 1, 2 oxygens, and 2 times 1, 2 hydrogens. So in this goal, elements have symbols and compounds have formulas that do use the symbols of the element. And the formula is written in such a way that shows you the ratio of how many elements there is to the next one. Why do we have formulas? Right here, this is the longest chemical name that has been printed, and you can see the amount of space that it takes up. This is an organic molecule, and organic molecules typically have a common name also, because then it makes it even faster. And this organic molecule has the name of tryptophan synthetase. But you can see that the number of carbons and hydrogens and oxygens and sulfurs reach way into the thousands for the carbon and the hydrogen. So formulas are just a shortcut way to represent these really, really long molecules, and even using a common name is even quicker. Let's review diatomic molecules. So diatomic molecules, these are elements that don't exist by themselves. And so here they are. We have hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. So they will bond with another element, or if there is no other element to bond with, they will bond with themselves. So they always have to have a buddy with them. So a good way to memorize this is the silly mnemonic: have no fear of ice cold bears, meaning polar bears. You also could look at the periodic table, and on the periodic table, the diatomic elements make a 7. And there are 7 diatomic elements. So starting with nitrogen and going over to oxygen, fluorine, and then down chlorine, bromine, iodine. And don't forget hydrogen over here in the corner. So those are your 7.